This is page 82, number 8. The first thing it says to do is to graph 3 points, negative 2, 1, 3, 1, and 0, 7. I made a pretty rough sketch over here of just those. It says that there is a quadratic function whose graph passes through these 3 points. Sketch the graph. So the first thing I want to point out is this point up here, is that the vertex? How do we know that's not the vertex? Yes? It's not in the middle, yeah. Halfway between negative 2, 1 and 3, 1 would be 0.5, 1, which is up here, or sorry, 0.5, which would be up here higher somewhere. So to graph that, it's going to be close, but it'll go a little bit higher past that point and then come back down. Oh, I missed it. You get the idea, though. Okay? And it wants you to find these equations in 2 ways. First, begin with that equation y equals ax squared plus bx plus c and use the 3 points, which is what, it says one of these values is essentially given to you. So I'll show you that one. And then the second part is to use that vertex form of the equation. So it says that your 2 equations do not look alike, but they should be equivalent. Check that they are. Okay. So let's start with the first step, the first one here. I'm going to kind of get this out of the way. Okay, we are using ax squared plus bx plus c, that y equals that. Now things they gave us 3 points. So the 3 points they gave us, we can substitute into that equation for x and for y. So let me write those 3 equations up here to the right first. So we have 1 equals a times negative 2 squared plus b times negative 2 plus c. And I'll go ahead and simplify that right now to 1 equals 4a minus 2b plus c. So that's using that point negative 2, comma 1. Second point is 3, comma 1. So I get 1 equals a times 3 squared plus b times 3 plus c. Simplify that and I get 1 equals 9a plus 3b plus c. The last one is 0, 7. So 7 equals a times 0 squared plus b times 0 plus c. Now that simplifies really nicely because 0 squared is 0 times a is 0. That's going to cancel out. 0 times b is 0. Gone. So then this actually gives us that 7 equals c. So c equals 7. So now to actually solve these equations, okay, we can substitute that 7 back in to these equations here and here. So I can just substitute that c equals 7 right there and right there. So now I'm going to make a little flow chart going left here. I know it's been somewhat complicated, but you should be able to follow me. So I have 1 equals 4a minus 2b plus 7. And then I have 1 equals 9a plus 3b plus 7. Now we have 2 equations, 2 variables. We want to solve for those 2 variables. Okay, the whole goal here is to find this equation, find a, b, and c, substitute those in, and you'll have your equation of the parabola. We already have c. C is 7. You can go put that right up here. C is 7. Okay. Does anyone remember how to solve 2 equations, 2 variables, algebraically? Paul?
The linear system system of addition, combining the two equations.
Okay.
They cancel out of there.
So we can add them or subtract them, but we're going to use elimination here. So I want to get all the numbers to the right side. Okay. Sorry, to the left side since I have plus 7. So I'm going to simplify these slightly to negative 6 equals 4a minus 2b. Negative 6 equals 9a plus 3b. Where do you that negative 6 came from? Subtracted the 7 from both sides. So minus 7 to both sides. Okay. So once I have that, I want to simplify, or I want to be able to eliminate some stuff here. So I'm looking at these numbers. And I think the easiest to eliminate are usually the smallest. If I multiply this by a 3 and this by a 2, I'd have a negative 6 and a positive 6, and then I can eliminate. So the thing is, when I multiply, I got to multiply the whole equation. I'm going to do that. And when I simplify those, multiply those out, I get negative 18 equals 12a minus 6b. And then I'll get 12 equals negative 18a. Uh-oh. I'll get a negative 6b. I just realized that I really didn't want to multiply that whole thing by a negative 2. I'll multiply by a positive 2 would have been better. So let me do that. Multiply by positive 2. That would make this a negative 12. This a positive 18. This a positive 6. And the reason I want to do that is I want opposites there. So when I add them, I get negative 30 equals 30a. And everybody see what happens here? These cancel. So what does a equal? Negative 1. So we already had c equaled 7. A equals negative 1. And so I could substitute those back into any of these equations. Would be fine. Let's see. I will use, it doesn't really matter. I'll use this equation right here. Why not? So I get negative 6 equals 4 times negative 1 minus 2b. Negative 6 equals negative 4 minus 2b. I ran out of a little room here, so this more. So then I get plus 4. So I get a negative 2 equals negative 2b. So what's b equals? And hopefully that looks right. So now I found A, B, and C. So assuming I did all my math right, my final answer would be y equals negative 1x squared plus 1x plus 7. And there's my equation of the parabola we had previously drawn. Questions there? Yes?
Isn't it when you add a negative to a negative, it stays negative, so wouldn't it be negative 10?
Uh-oh. Did I make a mistake there? I might have made a mistake there.
When you add the negative 4, wouldn't it be negative 10?
No. No. So right here, show me right here. So I multiply these, I got negative 4, so I have to add a 4 to both sides to cancel that.
Okay.
So add a 4, I get negative 2. Any other questions?